Let's now have a look at a concept in programming called scope. C is not the only programming language that uses the concept of scope. You'll find it in most advanced programming languages. So let's go now and talk about what scope actually is. Scope is a term used to describe the visibility and lifetime of a declared variable or function. Now what does that mean? Well, first of all, imagine a variable, any old variable that you declare. Let's call it x, put it inside main. We need to understand the visibility and lifetime of this variable. The visibility refers to the question, from what parts of the code may the variable or function be accessed? Well, consider our example, x, inside the function main. I think you'll agree that inside the main function, in other words from every line of the main function, you'd be able to write, say, x equals 5 without the compiler complaining about it. In other words, you could set or access the value of x quite comfortably on any line inside the main function. Okay, that's visibility. But that's not the whole picture, because just because it's visible inside main doesn't mean it's visible anywhere else. If you had a function, some other function in your program, call it anything, call it add or multiply or whatever you want to call it. Now, you go into that function. Could you write a line of code in that function that said x equals 5? No, you could not. You could only do that if there was a local variable declared in that function called x, but there isn't. X is declared in main. In other words, well, we kind of already know this, that a variable that is declared in one function is not visible in another. In other words, you can't use it in the function, in any other function but the one it's been declared in. Okay, so that's visibility. I hope you understand now the concept of visibility. You cannot see the variable, we call it C, we don't really see anything, but we call it seeing. You can't see the variable x from any other function other than the function it's declared in. Also, lifetime. How long does the variable continue to exist? Let's take this example again, but this time let's have the variable x sitting inside the function called add. Now the function called add gets called, and inside there is a local variable called x, and x will be hopefully used inside the function called add, and finally the function called add will finish. At that point, x will cease to exist. Now you may not have known that, it's not obvious from any of the discussion we've had so far, but that's exactly what happens. There is no memory space anywhere at that point called x anymore. If the function add is called again, then another box will be created called x, and that will again be destroyed when the function ends. Anyway, I'm going to go into that in more detail. I just wanted to help you with the concepts of visibility and lifetime so that you can then understand what I mean by scope. Scope is really just the combination of visibility and lifetime. Notice in that final bullet point there, I say how long does the variable continue to exist, but I don't say the variable or function continue to exist, because functions don't really have a lifetime. They don't really exist. They never really get created or destroyed as the program executes. They're always just kind of available to be called, but they don't really are created or destroyed. Anyway, let's move on. Variable scope. We're going to look at the scope of variables, we're going to look at the scope of functions, and we're also going to look at the scope of preprocessor directives, but we'll focus most of our attention on variable scope. Now, I want to talk about blocks first. Remember what blocks are? Remember, blocks are things inside curly brackets, or a block is a curly bracket surrounding a series of statements. And from there, you might recall that, well, it's a block of code. It's a unit of code surrounded by parentheses, the curly brackets, not the round brackets. And some blocks have names. The blocks that have names are called functions. That's really all a function is. It's a block of code that has got a name. Some blocks may be contained within other blocks. In other words, it's quite possible to have a block that's situated by itself inside a function. Any old if statement will create for you a block. If you say if x is greater than 3 and you want to execute 3 lines of code, if x is greater than 3, then you'll need to put those 3 lines of code inside a block. And thus that block will be contained within whatever function you happen to be in at the time. So you'll have a block within another block. And you don't really need to know this at this point. There's a thing called a stack. If you happen to know what a stack is, then blocks, I will tell you that blocks are loaded onto the stack, and as soon as the block completes its execution, it is unloaded from the stack. And if you don't know what I just said then don't worry about it. If you don't understand stacks, you will understand them at the end of the next chapter. So, now that we know what blocks are, or we remember what blocks are, how do variables work in conjunction with blocks? Well, firstly, variables may only be declared at the start of blocks. You can't have a line of code that says, say, y equals 7 and then declare a variable called x immediately after that. You can only declare a variable at the beginning of a block. Okay, what else? If you declare such a variable, it is only visible, recall our discussion on visibility, it is only visible within that block or any of the sub-blocks. Now that's quite an important statement. This is really the definition of variable scope. A variable's scope is only in the block that it is declared in, or if that block happens to be a function, in the function that it is declared in. In other words, you can't access it from any other block. The only time you can ever access it from another block is if that second block is wholly contained within the first block. Okay? When the block is completed, and actually at that point it gets unloaded from the stack, the variable is destroyed. Any value that happened to be in that variable will be lost. You cannot access it anymore. Now that's quite important. I want to take a little moment here to explain the importance of that statement. A lot of people write code like this, and this is clearly wrong. They write codes like this, and they have bugs in their program, and they don't understand why they have a bug in their program. They call a function, and that function has a return value, and that return value is a pointer, and the pointer points to one of the local variables inside that function. In other words, they create a function called, I don't know, anything, add, and add produces, say, a result, and there might be a little local variable called result, and then the function add returns a pointer to that result. It might return the address of that result back to the calling function. The calling function might be main. And then main might attempt to do something with that address. It might attempt to write a new value into that address. But here's the problem. The thing that the pointer points to doesn't exist anymore. I mean, sure, it's a memory address, and the memory address is certainly still there, but that memory may now be being used for something else. That's the key issue. The memory that was being used may be now used for something else. And so you're pointing to something, but you really don't know what you're pointing to anymore, and you can quite easily crash the program if you do that. Anyway, that's enough of that. More on variable scope. Now, recall, we have something called global variables. Those are variables that are declared outside of all functions. Okay, so they're not declared inside a block at all, and they have visibility as well. The visibility for those is all blocks. If you declare a global variable, you can see it in every single block, and that is in every single function, in every single file. I'm sure you probably got that already by use of the word global, but it's worth saying that that's what global is. It has a different scope to any other variable. Now, here's an interesting issue. Two variables may be declared with the same name only if they have different scope. Now you might think, well, that's obvious. You can have two different functions, and you can declare a variable in one called x, and you can declare another x in the other function, and they're not obviously going to compete or interrelate with each other. Yes, and that is true. However, it also means that you can have two variables with the same name in the same function as long as they have different scope. In other words, you could put them in different blocks. You could have a variable called x, which is part of a function, and then you could have a sub-block inside that function with another variable called x, and that's perfectly okay. Very confusing, certainly confusing, and I don't recommend that anybody actually do that, but the compiler will allow it, and things will work. Furthermore, you could have a global variable, let's say you had a global variable called count, and you could have, let's say, another count within a function. So you could have a global variable called count, and you could have a local function-wide variable called count as well, and that is allowed. Your compiler will allow that. The program will compile and the program will hopefully work. So if you're inside one of these functions, and let's say there's a global variable called count and there's a local variable called count, and you say x equals count, which value does it pick up? Does it pick up the global one or does it pick up the local one? That's a really good question, and here's the answer. If two variables with the same name are both visible from a given point in the code, then the one with the smallest scope is used. So that means the local one is always used before the global one. If you're inside a small block, let's say about an if statement, and there's a variable in there called x, and there's another variable called x in the function itself, function-wide version of x, then it will take the inner one. It'll take the if-sized one, if you like. So it'll always take the smallest one. That's a rule. Compilers all adhere to that rule. Now, even though it's a nice hard and fast rule and it's not ambiguous at all, it's extremely confusing to read somebody's code where they're using two variables with the same name. It just doesn't read right. The compiler might understand it, but most humans won't. So I just encourage you, please don't do it. There's no real need to do it. Just be creative and come up with a different name. Okay, that pretty much concludes the discussion on variable scope. I will show you some examples in a moment, but I want to conclude the discussion on scope by first looking at the other two types of scope, function scope and preprocessor directive scope. Firstly, function scope. Now this function scope is very, very simple. All functions are considered to be global functions. That's pretty much it. Thus, all functions are available to be called from all other functions. There's no such thing as a local function or a function within a function. There is something called a static function, and I'm going to show that to you shortly. There's also something called a static variable, and that does slightly adjust this particular rule that I've got in front of me, but for the purposes of what we know so far, all functions are global functions. Okay, so their scope is, well, everything, the entire program. Finally, preprocessor directive scope. Now, most preprocessor directives, such as hash include, hash undef, hash ifdef, they have no scope at all. That means that they're just processed on the spot. Like when you get to the hash include directive, it just simply goes and gets a whole bunch of lines of text out of the header file and replaces the hash include line with those lines from the header file. In other words, there's no real scope involved, it just does something. It just does some text substitution right there and then on the spot. The same with undef and the same with ifdef. However, the hash defined directive does have scope. It is considered to be in effect, if you like, from the line where it appears. In other words, if you had an example of hash define max of 10, so you're defining max to be 10, in other words, you're going to do some text substitution in this file. Everywhere you see the word max, you're going to substitute 10. Those substitutions will happen from the line where the hash define appears until the end of the source file, and that's all. It won't appear above, any occurrences of the word max above the hash define, well, you'll probably just get some kind of error message. And there's a slightly more complex version of that, where if the hash define that we're talking about appears within a header file, and then the header file is included within a .c file, then the scope of the hash define, in other words, the area in which the text substitution is going to occur, is from the line that the hash include is on until the end of the .c file that the hash include line is in. Now, I know that sounds a little bit confusing, but just stare at that. Maybe you want to pause the video and reread over this a couple of times. It is actually quite simple. It is what you would expect it to be. It basically just says, if you ever see a hash define, it's from there onwards. It's not above there, and it's not in any other file. Okay, so let's go and have a look at some examples of scope. So here we are in scope.c. All I'm going to be using this program for is to illustrate where certain variables are visible and where they're not visible. I'll just walk you through the program first and show you what there is. There's a global variable called a. Then we've got a function. Inside that function we've got a function-wide variable called b. Then we've got a block. This is the block. Inside there we've got a function called C. And we've got a second block. It's got a variable in it called D. And then we've got main, and main has a function-wide variable called E, and then it has a block, and the block goes all the way down to there, and that block has got a subsidiary block inside it. And the outer block has got a variable called F, and the inner block has got a variable called G, and that's it. All these A equals question mark lines, don't worry about those, I'm about to explain what those are for. So, back up to the top of the program. What I want to do is fill in all these lines here, these A equals lines, with, say for example, B plus C plus D. Now if that line will compile, then obviously B, C and D are all visible at that point. I'm not saying that they are, I'm just saying that if A, B, C and D all compiled, then we would be able to see A, B, C and D at that point. Now obviously we can see A. Clearly we're going to be able to see A at this point because everywhere can see A, because A is a global variable. Can we see B? Yes, we can see B. What about the rest? What about E and F and G? Let's think about it. Well, where's C? Oh, we can see B because it's right there, it's just above it. Can we see C? I don't think we can. We can't, in fact, because C is in a smaller block, it's in a sub-block, and that's not visible out here. I'm not sure if that's immediately clear, but it's not. Let's try it. If you don't believe me, let's get rid of all this stuff and try and compile it. So we're going to compile. 6 errors. C is undeclared. Okay, so C right here is undeclared. So we don't have visibility on C at that particular point. I was hoping that we would get those error messages. So what I'll do now is I'll just continue through the program and I'll fill in all these lines A equals whatever just to show you what we have visibility of there at that particular point in the program. I'll make the list complete and you can study this at your leisure. I suggest that you open this up at some point from the CD and just read through it and make sure that you agree with everything that I've put in there. So this line is obviously going to be, we're going to have visibility on B and we're going to have visibility on C. Now up here we're not going to have visibility on C, only on B and A. So I'll continue on like that through the rest of the file. Okay, let's continue on. Okay, here it's obviously the same. We've just got visibility on A and B. We don't have visibility on C. Even though C was declared above us, it's just inside that little block. So the block has now ended at this point and C will have died with it. C will have been destroyed when the block ended, so we don't have visibility on C anymore. And here we will have visibility on A, B and D, and here it'll be B again, and here we've got a variable called E. We'll have visibility on A and E. Then we go into a block and we've got visibility on A and E and F, and now we go inside another block and we've got visibility on A and E and F and G, and that's all. Now we come out of that block, G will have been destroyed, so we're back to E plus F again, A, E and F, and then that block has now been destroyed, so we no longer have visibility on F, so it's just E, and that's the end of the program. So hopefully that will compile with no errors. Let's try that. No errors. Now the fact that we've got no errors means that I have been at least correct in saying that we have visibility on those variables that we do have visibility on. I may have skipped some, but I don't think I have. Like for instance, I may have not typed in the G there, even though G was visible, but G wasn't visible, so I actually don't think I've made any mistakes. If you'd like to check it yourself, please feel free. Anyway, so that's that particular exercise, and now I'm going to have another look at another scope file. This is scope2.c. This demonstrates the concept of preprocessor directive scope. In other words, we've got a hash define line here that we're saying max equals 10, and we're using that max here, and we're also using it here. I know these functions are very, very simplistic and they don't really do anything important, but never mind. I want to see whether this compiles or not. Now let's try it. And I've got some errors. Now, my first error is this. Max is undeclared. So, now where's that set to? It's set right up here at the top in the function called max. At this point, max, the compiler knows nothing about max, or the preprocessor knows nothing about max, because we haven't defined max yet. So it's pretty simple. I just want to say that the definition of max will only come into play after the hash define line and not before. That's very important. But it's anywhere after. It doesn't matter if it's inside a function or inside a block or outside a block. Hash defines don't care about blocks. They are just pure text substitution, and that's all they are. Okay? So that's it from our introductory discussion on scope. We now need to go and have a look at a very special aspect of scope. It's called the static keyword. That's in the next module.